Hello and welcome. I am Vaibhav and our today's topic is projection of lines. So let us begin with projection of lines. So first the notations. So following are the different notations which should be followed while naming the different views in orthographic projection. So let us suppose in our case our object is line AB. So now our notations would be, its top view would be denoted by small ab. Its front view would be denoted by A dash B dash, and its side view would be denoted by A double dash and B double dash. So these are the notation which we are going to follow throughout this complete chapter. So let us begin with projection of line. So what you can expect with this chapter? So in this, information regarding a line must be given, like its length, you can say a true length. Position of its end with HP and VP would be given, means above HP, below HP, or in front and behind VP would be given. And third, its inclination with respect to HP and VP would be given. Inclination with respect to HP would be given by theta, and inclination with respect to VP would be given by phi. And here our aim would be to draw its projection, means the front view and top view of the given line. So here we are having the simple cases of lines. So we are having total of 5 cases of lines. So first, a vertical line, a line perpendicular to HP and which is parallel to VP. The second case would be a line parallel to both HP and VP. Third case, you can learn a line inclined to HP and parallel to VP. In the fourth case, we will be learning a line inclined to VP and parallel to HP. And in fifth and final case, a line is inclined to both HP and VP. We will start learning from this first case and gradually we will move towards our fifth case. So let us begin first. So let us see first case. So in first case, line is perpendicular to HP and it is parallel to VP. So what is the case means? So let us see the pictorial representation for better understanding. So this is our quadrant system. As you can see, there is one plane HP horizontal plane and there is another plane VP which is known as a vertical plane. So we will be having one line in this HP and VP. So here is line. So as you can see, this line is now parallel to vertical plane, and if you extend this line, it must be perpendicular to HP. So let us take the two views of this line. So we will be taking these two views of this line. First, from this direction, it is known as your front view. So front view will be having one line on your vertical plane like this. So it is the line having the same length of our actual line AB. So this is nothing but the front view on your vertical plane, and it is denoted by A dash and B dash because we are denoting the front view of the line. So now let us take the another view, which is the top view of this line. So we will be observing this object from the top direction and we will be having its view as a point view. So you will be noticing A and point B. You will be noticing point A and B on the same point. So this will be a final point view of the line AB. So this is nothing but a point A and B without dash. These are the top view of your line AB. So now this is a 3D representation of your object. So this is orthographic projection of lines, but it is very difficult to draw in the actual practice in examinations. So we will try to convert these 3-dimensional orthographic views of line into 2-dimensional clearly understandable views. So in examination, it is required to draw this kind of view in which you need to first draw your XY line and you need to draw this vertical line above XY line and its top view just below this line in vertical fashion like this, the top view. So in examination, you require to draw this diagram and it contains the marks. So as you can see, we are having the front view as a straight line and you can have top view as a point view. So front view is a vertical line showing the true length, and here the top view is what? A point view. So whenever your line is perpendicular to HP and it is parallel to VP, your answer would be your front view as a vertical line showing the true length and your top view would be a point view, as you can see. So this is the answer for our first case. You need to remember this answer in order to understand the first case. Now let us see the second case. So second case is what? So a line is parallel to HP and parallel to VP. So let us understand it better by the pictorial representation. This is our quadrant system. Once again, you are having HP and VP. Let us take one line which is parallel to your VP and parallel to HP, as you can see. So this is our line AB. So let us take two views. First the front view and second the top view. So when we try to take the front view from this direction, you will be having one line parallel to your given line AB like this. So this is the line having the same length as that of the actual line. So this will be nothing but your front view, and you can say it as A dash and B dash because we are naming front view as A dash and B dash. Now let us take the top view from this top direction. So if we try to take the top view, we will be having this point like this. So we will be having line parallel to this actual line AB, and this is nothing but the top view on your HP. And always remember, your top view always lies on your horizontal plane. So here top view is denoted by AB. So now once again these views are in three-dimensional format. We will try to convert these views into two-dimensional clearly understandable format, which we need to actually draw into our examinations. So this is your final view in which we need to draw one XY line. Above XY line you need to draw the first front view just parallel to your XY line like this, A dash B dash, and you need to draw just below your front view in the same position AB, which will denote you the top view. Always remember, your front view always lies in the VP vertical plane, and always your top view lies in a horizontal plane. So in which, what is the final conclusion? So whenever your line is parallel to HP and parallel to VP, at that time your answers would be front view and top view both parallel to XY line, and both will show you a true length. So this is the conclusion. So you need to remember this conclusion for each of the case, and you can easily solve these cases in your examination. So let us move to a third case. So in which third case, let us see what is third case. Line is inclined to HP but it is parallel to VP. So let us understand this case by a pictorial representation. So we will be taking one line. As you can see, this line is parallel to VP, but it is some angle inclined with your HP, as you can see. So this is the inclination. So let us suppose if we are taking the inclination with respect to HP as theta, then this line is now theta degree inclined with your HP. So now let us take its front view from this direction. So when we take the front view from this direction, we will have the line of same length but making the same theta inclination with respect to your XY line, as you can see. And this line is your front view, that means we will be showing this by A dash and B dash. Now let us take its second view, which is a top view. So let us take the top view from the top direction. So we will be having one line, so here on your HP, as you can see, and this is lying on HP, that's why it is also known as AB. So AB. Now as you can see, this line is of a shorter length as compared to your true length AB red line. That means whenever you are having line inclined to any of the plane and parallel to another plane, so whichever plane line is inclined, you will have in that plane the view in a shorter length. So here line is what? Inclined to HP. That means it is confirmed that in HP you will be having its projection of a shorter length, as you can see. So now this is once again what? 3D representation of orthographic views of a line. So let us convert it into 2D clearly understandable two-dimensional format orthographic views. So these are 3D to 2D conversion of your orthographic views of line. So you need to draw just this XY line in examination. You need to plot this line at theta degree angle A dash B dash, which is your front view, and just below that you need to draw, below A dash would be a point A and below B dash would be a point B, and this would be your top view. So this is nothing but your required answer in your examination. So what is the conclusion here? So here whenever your line is inclined to HP but it is parallel to VP, your answers would be front view inclined to XY line and top view would be parallel to your XY line, and it would be of a shorter length because your line is inclined to your HP. That means your top view would be of shorter length, as you can see. This is the actual length of your line and this is a shorter length of the line. Now let us move to a fourth case. So in fourth case what happens? So here line is inclined to VP but it is parallel to HP. So let us understand it by pictorial representation. So we are having this line. So now this line is now parallel to HP, as you can see, but it is now inclined at certain angle phi with your VP. Now let us take the front view from this direction. We will be taking the top view first. Let us take the top view first. So when we try to take the top view first, so as you can see line is parallel to your HP. That means in top view you will be having a same true length of the line with the same length, and you will be having this top view as your AB. Now let us take the front view from this direction. We will try to take the front view from this direction. So you will be having the line of a shorter length. Why of the shorter length? So we know that a line is inclined with your VP. That means whenever the line is inclined to any of the plane, the projection views on that plane would be of what? Shorter in length. So here your line is inclined to what? Your vertical plane. That's why your line's projection would be shorter in length in vertical plane itself. So here you can see when we take the top view, we will be having a line inclined to vertical plane with the angle phi. So whenever your line is parallel to any of the planes, you will be having true length and true inclination of line in that plane to which this line is parallel. So now this is once again 3D representation of your orthographic projection of lines. So let us convert it into 2D clearly understandable views which you need to show in your examination. So let us draw these two-dimensional views. So these are nothing but your two-dimensional views. So what you will do is you will just need to draw one straight XY line first. Then you need to draw this inclined line of a true length. You can say it as a top view because it is resting on HP. So AB would be your line length. You need to draw this as a phi angle, and then after you need to draw just the vertical lines from these 2 points. You need to draw the horizontal line at any distance. You will be having a front view A dash B dash onto your vertical plane. So these are the 4 views. I hope you clearly understood these views. So what is the conclusion of 4th view? So here whenever your line is inclined to VP but it is parallel to HP, your conclusion is top view would be inclined to XY line and front view would be parallel line, and front view would be of a shorter length. Why? Because your line is inclined to VP. That means the views in VP would be of a shorter length as compared to your actual line. So now let us understand the 5th and most important case here, so which is what? Line is inclined to both HP and VP. So now let us see what I mean by line is inclined to HP and VP both. So suppose this is a line. As you can see, this line is not parallel to HP or not parallel to VP, but it is inclined to both HP and VP, right? So now let us take the front view from this direction. Let us take the top view from this direction. So whenever we take the front view from this direction, we'll be having one line inclined to HP by angle theta, or you can say here the angle alpha. And when we try to take the top view from this direction, we'll be having one line which is inclined to your vertical plane by angle beta. So the projections which we got on your vertical plane is nothing but your front view, and it is denoted by, as you can see, A dash and B dash. And projections what you got on your horizontal plane, it is known as your AB, and it is your top view. So we are having these views. Now it is in 3-dimensional format, so let us try to convert this into 2-dimensional clearly understandable figure. So before going to there, let us just remove this object first and let us understand what is our actual view. So we are removing this object. So now we will be having these 2 lines, and these are nothing but our required orthographic projections of a line. So now as you can see, it is still in 3-dimensional format. So let us try to convert this in the clockwise direction horizontal plane. You will be having this final figure. In final figure you will be having this XY line that you need to draw in examination. After drawing this XY line, you need to first identify your point A by projection of points chapter, and then after you will try to draw one line top view AB at angle beta, and from that line you need to draw a vertical line and you need to identify point A dash first, and from your point A dash you need to draw your inclined line at angle alpha, and you will be having one line of front view at A dash B dash at angle alpha. So here what is the conclusion? So whenever your line is inclined to both the planes, your front view would be image on your VP and your top view would be image on your HP. But here front view and top view would be not of a true length, but front view and top view are inclined at certain angle and both are of a reduced dimension. Because your line is inclined to both of the planes, that's why your front view and your top view would be of a shorter in the dimensions, and these are not parallel to your XY line, as you can see. So here both the front view and top view are inclined to XY line. No views are parallel to XY line, as you can see, and both front view and top view are reduced in length. Because why? Because both are inclined to HP and VP, so that's why both are in reduced length. So that's why we are having no views having true length. But in examination we will be having a line with a true length. So if we are not having its views in true length, so how to draw these views? Because our line would be in true length, and here none of the line is in the true length. So there is a problem that we can't solve this example because we are not having any of the lines of this example as a true length. In previous cases we have seen that one of the lines would be of the true length, and from that line we should draw the another views. But here in this case we are not having any of the lines of true length, then we should anyhow find a true length line, and then after we can solve this example. So it is the most important thing that we will be solving next. So let us suppose we are having this object from our previous case, and we need to draw the front view and top view of this line AB as shown. We have drawn this front view already here, alpha and beta, but actually it is not possible to draw alpha and beta without having the true length of the line. So what we will do is we will try to convert this top view of this line anyhow, and we will try to make it horizontal in next case. So what we will do is we will try to convert this top view horizontal, and we know that when we try to convert this top view of horizontal lines, whenever we are having any horizontal line, then horizontal line will give in another reference plane a true length. So when we try to convert this top view, as you can see, as a horizontal line, and when we try to draw one vertical line from this, and when we try to generate one point here, then we will be having one line generated here which will give us what? A true length. So this is nothing but what? A true length at angle theta. So this is how we have generated a true length of a front view by converting this top view horizontal, and we are now having this line finally of a true length, and this is how we can generate the true length. After having the true length, we can obviously draw any example. So here in this case, so note the procedure. Whenever the front view and top view are known but the true length is unknown, then what to do? So we will follow the same procedure. So whenever in examination, whenever you know front view and top view but you don't know the true length, and what you do, so you need to first plot your one of the top view or front view, then after you need to convert it into horizontal line. So how to convert it into horizontal line? So you will be using your rounder. Put your rounder into A, B, and try to take A as a center and B as a radius, try to draw it. So you will be having your point B1 as an answer, and connect your A, B1, so which will be a horizontal top view. Then after you need to just draw one vertical line from this B1, and you need to draw one line at a theta angle. You will be having your point B1 dash, and your line A dash B1 dash is nothing but your true length. Right? So now let us see the second case. In second case, what we'll do is, in second case, whenever the true length is known but top view and front view is not known, then what to do? So what we'll do is we'll find out point A and A dash by projection of point method. We'll then draw your angle of true length. So theta A dash B1 dash, which is a true length in VP at angle theta, and we need to draw one another true length here with AB2 as a true length here with angle phi. And then after what we'll do is we'll try to draw a straight line from this point B2 like this until we reach A dash horizontal line, and when we reach the A dash horizontal line, we'll mark this point as B2 dash, and then after we'll set on our rounder A dash B2 dash as a radius, and A dash as a center, B2 dash as a radius. We need to draw one circular arc like this. And so after making the arc, you will be having your point B dash. Now connect your A dash and B dash. So this will be your point with a dash. That means it is known as your front view. So this is nothing but your front view of a line. And now let us follow the similar procedure. So let us try to draw a vertical line from B1 dash until you reach the horizontal locus of your A, and then after take on the radius AB1 and make one arc, and you will be having your point here, which will be your point B, and try to join your point B and A. This will be your point without dash, and this is nothing but your top view. And we know that A dash and A comes on a straight line. That means your point B dash and B would be always on a straight line. So here, this is the diagram, which is our very important diagram. This is to remember for solving any of the examples. Don't worry if you haven't understood very clearly, but what is the main. So let me give you the glimpse what we have just done. So here the situation like in the first diagram, what we have done is we had two cases. First, in which we are having front view and top view, but the true length is not known. So what we'll do is we'll first draw the top view and we'll rotate it to horizontal, and then we try to draw the vertical line, and then we connect this line at theta angle, and we'll be having a true length. Now let us suppose if we don't have front view and top view, but we are having the two lines. So what we'll do is we'll first draw the two lines in both the cases. Then after we'll draw the vertical line from the two length until we reach the dash locus. Then we'll draw the radius r. And if we have the two length of this case, so we'll draw the two length at angle theta. We'll draw the vertical line until we reach the without dash line, and we'll try to draw the circular arc. Then we'll be having this B. So now study and memorize this diagram as your master diagram, and we'll be using this diagram to solve next all of the problem based on the projection of line. So this is the most important diagram. If you haven't remembered the previous series, or if you are confused with the previous series, don't worry. You need to just memorize and redraw this diagram for 10-15 times, and you can easily solve any of the examples very easily. So now let us understand this diagram. So what this diagram says. So here we are having total of 4 lines. As you can see, there are two true lengths here. There is first true length, and there is one another true length, and there is one front view above this xy line, and there is top view this below xy line, right? So now what will you do? So first of all, we'll solve the example of lines. So now what we'll do is we'll first identify the location of point A by solving the example of projection of point for point A. We'll locate point A and A dash. So we are having point A dash above and A below. Then after what we'll do is we'll have in examination true length must be given. So we'll try to plot the true length. So whenever it is given that true length is making an angle theta with HP, that means you will need to draw the true length from your point dash. And whenever your point is making an angle phi with a true length, that means you need to draw the true length from without dash point. And then after we'll try to solve this example. So this is the diagram that you need to remember. So now there are total of 10 things that you need to remember which is in this diagram. First, the true lengths. So A dash, B1 dash and AB2 are the true lengths. So let us observe in this diagram, A dash, B1 dash and AB2 are the true lengths. So in examination, often true lengths are given, so you need to draw this line by the help of your data. Then after you will be having angle of true length with HP. So whenever your angle of true length with HP is given, that means your theta is given, so you need to draw the line at theta angle. Then after the angle of true length with VP, that means a phi. So whenever angle with VP is given, that means a phi is given, so you need to draw the true length at phi. So you need to draw your true length line from your without dash point like this. So this will be your final answer. Then after you will be having angle of front view with XY, which is alpha. So here angle of front view, let us observe A dash, B dash, which is what? Alpha. So there are two possible cases of possible. Front view would be either a horizontal line, as you can see length of front view, or front view would be at angle alpha, and front view is always denoted by dash, so you need to draw your front view from dash point only. Now let us move ahead and let us see angle of top view with xy. So top view is what? Without dash point. So your angle made from your without dash point would be a what? Your angle with your top view. So here the angle with the top view is what? Beta. So here you can see the line AB is making an angle beta. So here this is the line AB. So whenever you are drawing line AB, your angle should be what? Beta, because top view is making an angle beta. Next, length of top view. So length of top view is what? Here there are two length of top view. First is AB1 and second is AB. So these are length of top view. Second, length of front view. So you need to remember length of front view is what? Here A dash, B dash, and second is what? A dash, B2 dash. Next, position of A. So in examination, position of A would be given like point above HP, below HP would be given. So you can plot the distances of A and A dash from the position of A, and you can plot position of B by the distances of B and B dash from position of B, right? And then after final, the distance between end projectors. So in examination of projection of point, we have seen that distance between the projectors should be 30 mm, right? So in that, the projector distance means the distance between A and A dash and B dash should be 30 mm. So here distance between end projectors means what are the ends of lines A and B, right? So distance between end projectors means you should first find out the projectors of ends. So A's projectors would be A dash and A. B's projectors would be what? B dash and B. So the difference between or distance between A dash A line and B dash B line would be what? Distance between end projectors. So here you can see distance between end projectors, the distance between A dash A line and B dash B line. Next, So theta and alpha are constructed with a dash, always remember. Phi and beta are constructed with a without dash point, always remember. B dash and B1 dash would be on the same line as you can see, and B and B2 would be on same line as you can see here. You should remember this. So true length is never rotated. You need to draw the vertical line from true length, and which is further rotated while you reach to another plane. And always remember your top view or your front view will be rotated, and then after you will find out the true length from that rotated views, right? So by keeping in this mind, we'll move ahead and we'll solve one example based on this diagram. So you need to draw this diagram and you need to keep it on one paper and keep that paper with you while solving the examples, and we'll be following this diagram. Few of the things would be given in this diagram and few of the things would be missing from this diagram. So you need to just add the missing things by drawing in your examination, and you can completely follow this course here to solve any of the examples, right? So let us start with the first example. So a line AB which is 75 mm long and it is 30 degree and 40 degree inclined to HP and VP respectively. The end point A is 12 mm above HP and 10 mm in front of VP. Draw the projections and line is in first quadrant. So first of all we must understand the data and then we can start the problem. So here one line is given. So line is always given in the true length. So here true length is given which is 75 mm, which is inclined at 30 degree and 40 degree to HP and VP. So inclination with HP is known as theta and inclination with VP is known as phi. So here theta and phi are given. Then after point A is 12 mm above HP and 10 mm in front of VP given. That means the location of point is given. So we'll be solving the example of point first and then we'll solve the example of line based on our master diagram. So let us first note down the data. So these are the data. True length is equal to 75 mm, theta is equal to 30 degree, phi is equal to 40 degree, point A is 12 mm above HP and 10 mm in front of it. Before writing data, don't try to rush to solve the example. Remember that. Now, very clear. So let us start. First draw the XY line. So we will draw first XY line. Then after we are having true length. So what we can do? We can plot true length at angle theta and phi. So let us first, before going to that, let us first denote the point. So before going to projection of line example, we need to solve the examples of point first. So here the location of point is given which is 12 mm above HP and 10 mm in front of VP. So let us remember the projection of point table. 12 mm above HP means 12 mm above XY line, which will be a point A dash, and 10 mm in front of VP means 10 mm below XY line. So we have plotted this point from projection of point chapter. One data finished. Now let us draw a true length at angle theta and phi. So theta angle is always drawn from dash point and phi angle is always drawn from your without dash point. So we'll start drawing this true length and angle theta from your A dash point. So let us draw one line at true length as the angle theta from your A dash point. So now the end point would be what? B1 dash, right? After getting this B1 dash, we need to draw another true length from your point A at angle phi. So we'll be drawing this true length at angle phi from your point A, and the end point of this would be what? Obviously B2. Then after we'll be drawing two locuses, one from B1 and another from B2. Then after define it by locus of B1 dash or B dash and define this locus by locus of B or B2. Now let us move ahead. So we are having true lengths already. So what we'll do is we'll try to draw a vertical line from this true length until we reach the A dash locus, and this will be a point B2 dash. After getting this B2 dash, take out your rounder, take A dash as a center and B2 dash as a radius, draw one circular arc, and you will be having one circular arc intersecting this horizontal locus, and this point would be nothing but what? B dash. Why B dash? Because B1 dash and B dash is the locus. We already have this B1 dash, and the next point would be what? B dash. After getting this B dash, try to connect this B dash with A dash. This is nothing but a dash point connected by a straight line. So that's why it is known as your front view. So let us write down front view over there. Then after you need to draw this vertical line, because we know that below this A dash we are having point A. That means that below this B dash on this vertical line we will be having point B. And point B would come where? So on this locus of B2 or B. So we will be getting this point B somewhere here. After getting point B, just connect your point B with your point A. These points are without dash point. That means what? This must be your top view, right? So that is all from my side. If you enjoyed the lecture and my teaching style, do not forget to like, share and subscribe to my channel. If you have any doubts, any queries, feel free and comment down below. Keep learning, stay connected. Bye bye.